All right, sounds good.
So it's 4 p.m. Welcome everybody. Thank you for joining us today, this morning, this afternoon. Today we are happy to have our first WMUG NL Tuesdays, and we're kicking off with Johan Arwidmark, and he will give a session about maximize Windows 10 and ConfigMgr Network Performance. But first, before moving to Johan, we would love to thank our sponsors, because without sponsors we are not able to organize. We are able to organize sessions like this, but hopefully we are back on premises really soon, and then we need to have some at least some money to invite speakers. Thanks to our sponsors. Follow us on social media and Twitter. We are planning to do this every week. Unfortunately, next week there's another big event happening around Windows Virtual Desktop. So next week we will skip, but the 5th of May we will be back with the WMUG NL Tuesdays. So stay tuned, follow us on Facebook, Twitter, and go to our meetup, and then you will be notified about the next speaker. So, Johan, thank you for joining us. For you, it's morning, all in the US. So I'm happy to give the floor to you.
All right, thank you so much, and thank you guys for having me. It's indeed early morning. Well, not early morning, but it's 9 a.m. in Chicago, or rather outside Chicago. So let me just go over and share my screen. I think that will override yours, I'm afraid, but can you see this window okay? So a little bit of delay, so we're just waiting for the image to come through. Thumbs up?
Yeah, it's all good.
Oh, perfect. So, as mentioned, my name is Johan. I'm going to be a host for the next hour or so. We have as many opportunities for asking questions as you want. I absolutely love questions. So if you have any, don't hesitate to just type in the chat, and Peter has been promising to help out as well, monitoring that stuff. So hopefully that should be okay. I've been doing this for a while now. Started off with OS deployment and imaging when I was about 16 years old, and that was some 30 years ago. So I might not have seen everything, but I've seen a lot. So again, if you do have any questions, don't hesitate to just go out there with them, and we should all be good. And this is a beautiful picture, of course, of downtown Chicago. We live an hour and a half west of Chicago, so it's basically in the middle of nowhere. City or town or village we live in is about 1,000 people, which is quite interesting. Decided to build a house out here because trying to buy a house closer to Chicago is like, yeah, they start around $1 million. I'm like, I don't even have that cash on me. So yeah, you know the deal. So I work for 2Point. I'm on Twitter. If you don't follow me, please do that, and also follow the user group alias as well, of course. Anyhow, this session is about what technologies can you use to make ConfigMgr as well as your network team just a little bit more happier, especially now in the Windows 10 area, because if you have been working with Windows 10 for more than like 4 seconds, you quickly realize it's a little bit more, how do you say, talkative, chatty on the network compared to what Windows 7 ever was back in the days. And as a good illustration of that, I think my favorite point is, well, I like Paint, so I use Paint a lot. If you deploy a machine, and that could be a Windows 10, 1809, 1903, or 1909, or whatever you're deploying, say that you do that on a Friday afternoon, you deploy a bunch of machines, and then you leave the office for the weekend, and I guess these guys, you deploy it from home. Yeah, you know how it is. But you leave the machine running for a day or two. When you remote into that machine back again on Monday, you're going to realize that that machine has been downloading a lot of stuff over the weekend. So what data is it exactly that this machine has been downloaded? Well, it's usually not security updates, because if your image is already patched before you deploy it, you don't have to worry about that. But if it wasn't, yeah, it's going to be another gig of updates too. But these numbers here, they're actually native application updates in Windows 10. You know, all the stuff that you have on your start menu and stuff. It's a lot of data coming down initially. And after that initial payload, every single month, you will see quite a lot of data coming down to the clients. And by default, if you don't do anything, and depending on what version of Windows 10 you are, et cetera, and how you have configured your policies and whatnot, you might end up in a scenario where the clients, each and one of them, are going to Microsoft CDN servers, get the content, and download to that client. So first over the ConfigMgr WAN link to a remote site, and then over the internet connection to internet if you have a central internet connection. And then the second client is going to do the same thing, and the third client is going to do the same thing. And imagine if you deploy 50 clients, or upgrade 50 clients to whatever version of Windows 10 you're upgrading to. That's going to be 50 gigs of data, at least, that has to come down over a 10 megabit and a 45 megabit WAN link. That's not really ideal. So what Microsoft did in early versions of Windows 10, they enabled peer-to-peer in Windows 10 as a core for this type of data. And then it didn't take long for the ConfigMgr team to also start to add in some support for these technologies. And the coolest thing is they actually already had it. Because back in the days, around when Windows 7 came, there was another peer-to-peer technology available called BranchCache. Still works. Actually worked great in Windows 10. But it can already do that together with ConfigMgr. But what Microsoft were doing, they start to add in more capabilities, more advanced scenarios for peer-to-peer. But the overall idea is to simply reduce the traffic that goes over the WAN link by simply allowing clients to get content from each other. And the tricky part now is all these different peer-to-peer technologies, delivery optimization, peer cache, BranchCache, they do overlap a little bit. They are configured differently, and they support different type of content. So you can actually have all three, even though it's a little bit messy, but at least you need to pick two. So why do you need to pick at least two? I go back to my little list here. Well, bottom line is that these guys are the ones that can do peer-to-peer. This one is the only one that can peer-to-peer application updates for Windows 10 and store application updates for Windows 10, Win32 apps from Intune, and Office updates that are not coming down through regular packages in ConfigMgr. And they're expanding this as well as time goes by. So now even Office Setup will be able to use this. But so we use this today. We use primarily for the native updates in Windows 10. But these two, they are being used for everything that ConfigMgr does. So every package type that you have in Config Manager. So software updates, images, boot images, regular application model apps, legacy packages, driver packages, and all that fun stuff. They have to be used by either of these two. So you will have to combine them. But the thing is, if you do this right, you can usually achieve up to 90% reduction of traffic that goes over the WAN link. So in addition to these peer-to-peer protocols, there are also technologies in Windows that allow you to, in this case, throttle traffic. That's bits that allow you to, okay, so you do have to get something over the WAN link. How fast can you be allowed to do that? And then we have what I like to call the opposite of bits, LED-BAD. That's a technology that was made available about 2 years ago. It's just a checkbox on your distribution point. It does require server 2016 or 2019 on your servers, but when you enable this one, it tries to maximize the use of that WAN link. 100% it tries to use, which normally upsets networking folks a little bit, but I'll come back to that in just a second. And then we finally, last year, we got a new friend called Microsoft Connected Cache. That is also a setting on the distribution point. And this does not require 2016 or 2019. This also works on 2012 and 2012 R2. But that's a local cache server that you can enable on the DP itself. So if you have a distribution point here, it's supposed to be a DP. And normally when the client needs an update for a native app, as I mentioned before, it's going to go to internet and get that update. But you can actually have the DP doing that on behalf of the client. So if you're through client settings or group policies or whatever you prefer, you can configure clients to use a connected cache. And then the client is going to ask the DP for the content. The DP is going to get the content on behalf of the client, return it, store the content in its cache, and at the same time also stream it down to the client that requested it. So now it obviously means when the second client wants that content, it doesn't have to go to the internet, but it still have to go to the DP and get the stuff and back again. Beautiful thing is, this one also works with peer-to-peer. So you're just reducing basically how far the first client has to go to get the stuff. Do we have any questions coming in yet?
Nope.
Oh, how many people are attending, out of curiosity?
Currently 55.
55, that's a pretty good crowd in a Tuesday afternoon. Guess most people are from Europe. I'm assuming that at least. All right, back on track. And then, of course, there are other third-party extensions that extends this beyond what ConfigMgr and stuff has in store. But when you want to start to play around with technologies for network infrastructure, your networking team usually is not fully supportive of you testing all of this in production networks. So what I recommend when you start to learn about these technologies, make yourself build a lab that you can play around with. So at the very least, I recommend get a virtual router going. It can be a Windows server. I use open source pfSense router most of my times, but for example, here in my lab, I have a bunch of them, but I have one router. It's just a virtual machine, but this machine and actually has a bunch of different networks to it.
Johan.
On these networks, yeah.
We have one question from Jörg.
Yeah. Yes.
Are there any limitations with the connected cache?
There are always limitations. It requires DP for now in the first place, but we've been pretty successful with using the connected cache. What I found in the setup is in ConfigMgr 1910, there was a little bug in the install script of it. It works perfectly in 1906, looking good so far in 2002, but in 1910, it just wouldn't work. So I can actually show you that little feature, as I call it. But when you enable this on the DP, this checkbox here, enable cache, it didn't take effect. And you waited 15-20 minutes, it still didn't work. The trick to get it to work was to simply go in and change one of the values here after. Change it from 100 to 105 or whatever, just do some change. And then the script that configures the connected cache finish the work. So if it doesn't work when you enable it right away, just go in and change one of the properties. But this is only if you are on 1910 or ConfigMgr. Other than that, it's been working pretty good. The default recommendation for size has been more than enough. We usually see between 40 and 80 gigs of usage, depending on how much stuff you have. But yeah, working well. That being said, it's a new technology. Usually takes a few iterations until it gets perfect, but so far it's been quite nice. All right, I hope that answered the question. So back, any more questions, by the way?
Nope.
Nope. All right. So I recommend getting a lab. And as I showed you before, I have a virtual machine with a bunch of different network cards. And the cool thing about pfSense as a router, first of all, it's free, which is kind of nice. But it's also, you can set up limiters in it. So I can simulate like real crappy networks. So if I go into the router, super secret password, and start to poke around on the traffic shaper options in the dashboard, I can configure different type of limiters. So I can say, all right, this connection 155, this connection 45 megabit, this connection 45 with a latency of 50. Or I can do and configure package losses, and I can basically say drop 1% of the packages to just fake a really poor connection. Or if you do a just really dirty and quick bandwidth limitation, it's not perfect, but it's instance. It doesn't require any change in the firewall policies, but you can actually go into the interface itself in Hyper-V and just set it to bandwidth max. This is only for download though, not for upload. But in ConfigMgr, when we do most of our testing, there is so little data that is being uploaded. It's a little bit of inventory here and there, but it's also usually the download of data that we're concerned about. So it actually works fairly well to just set limits in Hyper-V too. So anyhow, cool stuff. Get a lab going, find a server. It doesn't have to be fancy. It can be a 4-year-old Optiplex, 7040, whatever you can get your hands on. i7, 32 gigs of RAM, and 1 terabyte NVMe SSD. This is a very good start for having a ConfigMgr lab. You can have a domain controller, site server, a DP, and 4 or 5 clients running, and this machine won't even flinch. And this is a machine you can get used on eBay for $200-300. Buy some memory, buy a disk, and I don't know, maybe $500-600. I have no idea what is in the local currency, but it's not stupidly expensive. Your manager should be able to get that machine for you, or the next time you order a batch of machines, just keep one of them and use as your lab server. So Peter, out of curiosity, what's your lab server look like?
My lab server is in Azure.
All of it? Dang.
Yeah.
I used to have that, but it happened twice that I kind of forgot to turn it off.
No, yeah, you have auto shutdown.
Yeah. So I started
With
doing
a
it
new
local.
feature, most likely. So yeah, it's all in Azure, and I still have a, what is it, HPZ 600. Yeah, under my desk, but I hardly use it.
So in my lab, I have a slightly larger lab environment. I have probably about 100 VMs. Running these in Azure is going to be a little bit costly. So I decided to opt in for a local server, and I actually got one from my wife as a Christmas present. So this is a nice beefy server, a few CPUs and a little bit of memory in it. But I can run about 80 VMs at the same time before it starts to hiccup. And this was $1,000 on eBay. So I have to buy memory, of course, and disks, but dang, it was nice. So it's an HPC 840. It's a workstation that I got used. So cool stuff. Anyway, get a lab somehow. Don't care how you get it, just get one. Or use Azure as Peter does, but be worried that if you forget to turn everything off, it can be costly. I ran out of $1,000 per week for a little while. So my manager was a little bit upset, to say the least. So start with the different technologies. ConfigMgr is config manager only. It is supporting everything that ConfigMgr can possibly deploy, but it cannot peer-to-peer config manager policies. And you wouldn't think that is a big deal, but config manager policies can actually generate quite a bit of data, and especially in larger environments. So it is actually a big deal. What I like about ConfigMgr is that it supports OSD out of the box. So you can even do imaging using peer-to-peer content. It is using the config manager's own client cache. So as soon as one client has the stuff, then another client in the same boundary group, if that client is requesting the content, the management point is going to retrieve the first client as a source. So I have been doing over the years on my blog, that is not my blog, that's a one I share. If you search for ConfigMgr, there are a few things that I sort of learned the hard way about it. But first of all, when you set it up, it's just client policies, very easy. But I do not recommend enabling this everywhere. We have seen customers trying that route, and it simply doesn't turn out very well. You can think of this as, say that you have a branch office with 100 clients. You would basically turn them into DPs, all of those 100 clients. That's not what you want. So the trick to get peer cache successful is usually pick a few clients in every site and make them available as peers. And when you deploy stuff in your environment, you deploy to them first. So in my lab here, let me go over to this little friend here. I have a few different site servers. I go to my collections. I have a collection that I named peer cache sources. And in this collection, I've added a few machines from Chicago and a few machines from New York. Because in my boundary structure, I have configured different boundaries, IP ranges for New York and Chicago, and they are in different boundary groups, these boundaries. And in my client settings, I have simply done a peer cache source client setting. And in the client cache setting, this is the one that you enable. And when you do, I also recommend you to bump up the cache size a little bit, because remember, ConfigMgr client is, or peer cache is using the ConfigMgr client cache to peer content to others. So the default of 5 GB it's not going to be very useful to store a lot of packages for others. So bump it up to something that it makes sense. So I enable this client setting on a bunch of machines, and they turn into peer cache sources, meaning they can peer to others. And then when I do my various deployment of packages, software updates, whatever I'm deploying to this collection first. And then I deploy to everybody else. Because you want to make sure that these peers have the content before you start into other mass deployments. Because there is a difference between branch cache and peer cache, and peer cache requires that the entire file has been downloaded before it can start to peer to others. Branch cache, as soon as one client gets like a block of the file, it can start to share that block with others. So branch cache is much more effective, and you don't have to deploy in rings this way. But peer cache, you have to. Otherwise, it just will work badly for you. But something that is interesting is that when you enable this, as you can see here, I have a few clients in this collection. There are a bunch of tables that is going to be updated in the database. So let's see where I put that one. Come on, you. I promise I clicked. I thought I had a screenshot. Apparently I didn't. All right, I can show you instead. It's not that complicated. If you go to your site server, you go to tables, not views, do a filter, and you filter for the magic word superpeer. Going to show you 4 different tables. And once you enable this, what you're going to see is that in the superpeers table, it's going to list all machines that have superpeer enabled on them. In this case, my 4 machines. But it's also going to show you, once you start to deploy packages to them, each and every client is also going to report up to the management point and saying, hey, I'm a client with this resource ID. I have the following application model app in my cache. Or it could be that the following client has the following legacy package in its cache. So this way, the site server always knows which clients that have which content in which cache. So when other clients requests it, it can be forwarded to that machine. So it's not yeah.
Sorry, I have a question from Jörg again. Does peer cache make sense whenever you have a local DP?
Usually not. Depends a little bit on the load of that DP and how many clients you have, because some scenarios, if you have a slow DP or a stressed DP and you have a bunch of clients getting stuff, if other clients can do that download, well, it's going to offload that DP quite a bit. And there is actually a setting now, I forgot which version they added it in, but on the boundary group itself, you can a little bit control that behavior. So you can say that, all right, if there are peers, you can either say use them, that's the default behavior, or you can say no, try to use the DP first and then go use a peer. But usually, if you have a bunch of clients out there with the content, why not use them? Why have every single client go to a single server to get the stuff when you can share the load with others? I mean, think of it how switches are built. Say that you have a fancy 24-port switch. Imagine that your DP is connected with only a gigabit port. So this is your DP. Whoops, It's not the DP. DPs are blue. We agreed on that before. So this is a DP. If you have a bunch of clients that are also hooked up to the same switch, and they all want to download content, guess where the bottleneck is going to be? Yep, here. But if you have some machines that actually has stuff peered to them, it could very well be that this client is getting from that peer, that client is getting from that peer, and they're all both doing this with gigabit speed at the same time, because the backplane in the switch is usually capable of way more than just 1 gigabit. That could be 24 gigabit, it could be 48 gigabit. So you're basically maximizing the use of that local switch rather than the poor link up to the DP. So there are scenarios from a load perspective, bandwidth perspective, where it totally makes sense, even when you have a local DP, to enable it for some of the peers. I hope that answered that question there. Was there anything else going on?
There was an older question from Harris. What are your thoughts on having a lab on an Intel NUC? I know you had them back in the days.
Oh yeah, it works just fine. The Intel NUC are, as you probably guys know, like super small devices. They're like 4 by 4 by 2 inches or 5 by 5 by 2 inches high. They work just fine. They go for i7s now. They can have a 2 terabyte SSD in them, and they're pretty good. They're quiet. They're nice. You can stack them nicely in the living room. So yeah, I actually see companies building clusters with them for lab purposes. So yeah, I like them fine. The reason I use it as slightly larger machines myself for labs is I can punch in more stuff in them. More memory, more disks, etc. But yeah, it works. Right. So peer cache, that's how you enable it. That's how you make sure it works by looking at the database and see that it's actually doing. And this is a screenshot from one of the logs where you can see that when a client was asking for content, it actually listed 2 of my peers as the first 2 options, and only as the third one, it gave me the DP for a particular package. But this is how you can see by peeking into the CAS log and see what's going on. Yeah. Next up, we have BranchCache. In my opinion, this is a better peer-to-peer solution than PeerCache is. It's been around longer. It doesn't require that the entire file has been downloaded first. It can start to peer immediately. It does require, if you want to do OSD, you need to add in BranchCache to the boot image because it's not enabled by default. So you have to do that. The company I work for, 2Pint, we have a little utility that you can download for free that does it. But if you Google around a little bit, you will find other community snippets that through PowerShell done the same thing. But either way, you need to have it to get imaging during OSD. A cool thing about BranchCache, though, for imaging is that this is the only technology, including third-party, that I know of that can share content while in a Windows PE. PeerCache does not, other vendors does not, but BranchCache does. So even during the imaging part, while the machine is in WinPE, if you deploy other machines at the same time, they will also share. So that's pretty cool. There are 2 versions of BranchCache out there. One for Windows 7, that's version 1, and one for Windows 10, that is version 2. There used to be a little bit of interesting scenarios when you have them mixed and matched all the times on different subnets, but these days, don't see too many Windows 7s anymore, thank goodness. So you don't have to worry about that. Basically, everything is Windows 10. Enabling BranchCache is fairly easy, but it's also fairly easy to get tricked. Because in ConfigMgr, there is a client setting to enable BranchCache. Don't use it. In Active Directory, there is a group policy to allow you to configure BranchCache. Don't use it. The thing is that they don't allow you to configure all the BranchCache cache settings, like the port number. So any guess what port number it's using by default? It's using port 80. Can you think of any other application that might be using port 80? Like a web server or Skype? When you have those apps running, the BranchCache server service won't start, and there will be very little peer-to-peer happening at all. So what I recommend is that you use ConfigMgr and a configuration item to configure BranchCache. So we have it available for download on our GitHub page. So if you go to github.com, try to spell it somewhat correctly, to parent software, and you go to BranchCache, and you go to, we call it the BranchCache tuner, but this is just a cab file that you can import to ConfigMgr. And when you do, you get a configuration item, obviously. And I have a few different versions, but the one that is current right now is version 10 or 1.0. And if you look in this configuration item, it's basically two PowerShell scripts. One that makes sure that BranchCache is configured correctly, and one that controls the BranchCache cache size. Because BranchCache, unlike PeerCache, uses its own cache. It's a Windows component, it has its own cache. But if you look at the distributed script or distributed mode script, there is one for discovery to make sure that the settings what we're looking for. And there's a remediation script that actually sets them if they're not what we're looking for. But if we start to look around in this script a little bit, I can actually copy it over to ICE so it's readable. It would be so awesome if they could put in a decent editor in these dialog boxes, because they are just painful to try to do changes in scripts and to view stuff. That's maybe I should do a frown something. Anyhow, what this PowerShell script does, it allows you to override settings like the port. We also bump up the time to live value, because BranchCache by default only stores content in the cache for a month. How about 6 months? And then we're making sure that everything else is right, service is started, using the right port, eventually that the firewall is open, yada, yada, yada. So basically, it's a configuration item that we usually run daily or every second day that just makes sure that BranchCache is working on the clients. Because otherwise they will all start to go to the DP for content instead of getting it from a local friend. The other one is a little bit more creative. The other one is for the cache size itself. And if you start to peek into the beginning here of that script, it's going to take one of the functions. See, we are setting different sizes depending on how much space that is available on the disk. So in this example, if it's less than 10%, we give it 5%. If it's less than between 10 and 50, it gets 10. If it has more than 50% available, we give it 20. So just some dynamics, and basically saying that if there are more disk space available, cache more, because that will increase the peer-to-peer efficiency, basically. So to test BranchCache, making sure everything works, it's fairly easy. I can go to a few clients that I have, and I can open up a little bit of PowerShell, and I can nuke the cache completely, clear it out, both the ConfigMgr and the BranchCache cache, and I can do that on a few other clients as well. make sure there is nothing there. And in the cheap version, if I go to Software Center and download some stuff, like here I have a sequence that pre-caches content for OSD, but I have a few test packages that I can download. Before I start that download, if I open up Perfmon, which is not an exact science, but I can at least do it. And go to report, get rid of the CPU. And when BranchCache is enabled, there is some BranchCache performance counters that you can add in and look into. This allows you to see, let's see if I can get Zoom it running on this little friend. You can see how many bytes that were coming from a cache or were coming from, coming from a server or versus coming from a cache. So this means it came from a local friend. This means it came from a distribution point when it says server. Same means you also have up here. It works a little bit differently in the way it represents the data, but it gives you an idea on how you're doing. So if I leave that one running and start to download the package, it's going to take a little while because the client sometimes gets a little bit upset when you just nuke the cache for it. But usually it comes pretty quickly. Come on.
While we wait, maybe a question.
Here we go. Here we go. The download started, so give me a second.
Oh, okay.
And you can see now that the bytes from server are slightly increasing. And this was because I nuked the package from the client, so there are no friends available. Yes, now, question, yes.
Maybe you will cover this later on, but how different is peer cache versus delivery optimization when you do feature updates or other types of large deployments of applications?
So you cannot really compare them because they use different data types. Delivery optimization currently cannot do peer-to-peer or ConfigMgr packages. It can only do other stuff. There is one rare exception for DO, and that's for software updates, where if you enable a specific setting for Delta updates in ConfigMgr, where there is currently a bug for third-party updates, but that's another story, it's going to use DO for that very specific package content type. But for all your usual stuff that you have in ConfigMgr, all your images, all your see what I have going here. I'm just going to close this one. Maybe too many windows open. So all this stuff, driver packages, images, boot images, applications, packages. You can only select between BranchCache and peer cache. DO cannot do these type of packages. So you need to pick both, no matter what you like it or not. In the long term, I expect more and more content will be moved over to delivery optimization. But we're talking years before that's going to be, if even ever, a reality. So for now, you simply have to combine them too. That's all. Obviously, the company I work for, we cheat quite a bit when we do things. We have developed dashboards that allow you to see basically everything that happens in real time on your network. So I can prove where content is coming from. So now I can see that apparently somewhere someone is downloading a package. I know who that someone is because it was me. I just started to download. But it shows me that in real time. And it also shows me from where it's getting content. And since this was the first package from that client from a DP, like 99% of that traffic is going to be from the DP itself. And since I have enabled LEDBAT on my DPs, I see that it's actually LEDBAT traffic that is kicking in. So I'm seeing the same info as I saw in Perf1, but just with a dashboard to visualize the content. So that download is completed. If I go now to a second client on the same network and download the same package, if BranchCache is functional, or PeerCache for that matter, it's going to now try to do peer-to-peer of that content. Because remember, I deleted the cache from both these clients. Come on. It's coming. It's ConfigMgr. A little bit of patience. Here we go. Starting to download. You see it's going more quickly now. And if I go back to the dashboard, you start to see that almost all the traffic is now green down here. And the speed went from a few hundred kilobytes up to about 60, 70, 80 megabit per second, because it's now bringing that stuff from a local friend rather than over the WAN link. But without information like this, it's kind of more difficult to prove that things are going well. It's just hard to see what's going on. What you have in ConfigMgr, though, I have to admit that it's a nice little dashboard they put together. This one here, that will show me how efficient I have been on a given network on a given amount of time. But the drawback with this dashboard, it's 24 hours behind. That's not exactly real time, is it? So yeah, you can learn today that you had a problem yesterday. Real time is usually more efficient. But this is just visualizing the traffic, the core underlying infrastructure, PeerCache, BranchCache. They did that one works as they are. So if you want a step-by-step guidance on how to set them up, I highly recommend go back to my blog, Deployment Research, and can search for the keyword reducing. And I did a guide to guides basically a while back. This is Frodo from the Rings. But it's basically step-by-step guides on how to set up each of these technologies that are using peer-to-peer in the backend. So we have one more to touch, and that is delivery optimization. That one we configure through group policies. And which policies we use depends on what version of Windows 10 you're on, because ConfigMgr and DO didn't start to get really great until 1803. But let me show you what I'm talking about. Delivery optimization, in my opinion, works best when you're using a group to define what machine then can talk to each other. I'll give you an example. Back to my little drawing here. Did I delete you? I must have closed it. Dang it. All right. I draw this one quickly. Imagine that I have multiple sites. They are connected with a link of some sort. If you have a bunch of clients here, and you have a bunch of clients in the different locations, would it be wise to configure delivery optimization in a way so that clients in both locations can peer-to-peer to each other. We actually had clients testing this successfully, I might add. Basically having this client peer into this one peer into this one peer into this one peer into this one too. Basically creating a mesh, a storm of packages going back and forth over the wire for content. Their network was down to a standstill because someone applied a policy that said every client can talk to each other. Now, what you obviously should be doing is that you should configure it so clients over here, they can talk to each other, and clients over here can talk to each other, but they can absolutely talk to each other over the WAN link. That's not how you set up peer-to-peer. And in ConfigMgr, if you're lucky, one of the few lucky organizations where your boundary groups are perfectly matching your physical locations, yes, by all means, allow ConfigMgr to do that grouping for you. Because in the options here, this checkbox also means set DO. Not sure why I did the opposite, but if your boundary groups are not matching, like say you have a single boundary group that covers a lot of sites, don't use ConfigMgr to set the group ID. Because then you will start to see the scenario I was talking about before, where you simply have a gazillion of clients talking to each other over a WAN link. If you cannot set it for boundary groups, use group policies, use a script, do something. It's just a registry value together with the ID itself. That's how you group them together. And this works remarkably well. Other settings I recommend are these guys. Bump up the cache size a little bit. Allow it to serve on battery, because these days a lot of machines are on battery. Download the group mode, of course. The cache age, by default, is just a few days. Bump it up to at least a month. If you want to download how the speed of which a client can get these updates, by all means, go in and set it. And this one is quite critical. By default, DO will not peer content unless that content is 100 meg or more in size. I would prefer to be a little bit more effective than that, so bump it down to 1 meg. Last one here bit me so hard when I started to do testing of this a few years back. I just couldn't get my VMs to peer to each other. Turn out that I had set all my VMs to be of 2 gigs rather than 4 gigs. And there is a default limitation in DO that says it will not peer unless you have 4 gigs of RAM, which is never a problem on a physical box, but in my VMs in my lab, I only had 2. So since then, I'm always allocated 4 gigs now, but back then I didn't. So this one is also useful. This little policy setting, which requires 1803, basically makes the client look around a little bit longer for a friend with content. So that also increases the efficiency of DO. Yeah. Any questions at this point?
Don't think so.
All right. Just to give you an idea of what you can achieve. This is it's about 2 years old now, almost a year and a half. Microsoft, of course, using these technologies internally as well. And the screenshot is terrible, but you can see it probably. They are in their major sites they are well over a 90% efficiency on content. And you can see that about 2/3 of their clients are using other peers as sources. That's pretty good. That's your goal. If you can get it to 90%, you're king. More realistically, organizations are typically between 50 and up to 80% efficiency. But still, with a little bit of clicking in your environments, you can reduce 80, 90% of the traffic over the WAN links. That's pretty good, especially these days. My goodness, I spent my last few weeks just talking to organizations about doing stuff like that, because guess what? There are more people working from home now. VPN concentrators and other areas that didn't have so much traffic in the past that suddenly start to have traffic. And think of it, ladies and gentlemen, if you have a bunch of clients at home, so basically every home is its own little site, and they are all VPNing in to an office. Is it wise to enable peer-to-peer on these VPN clients? So they start to try to get content from each other? Not. It's a pretty bad configuration. Luckily, BranchCache detects that and just says, no, this is stupid, don't do it. But other technologies might not do that for you. And bandwidths and policies, you may want to apply them differently. Another cool thing, though, say that you have a remote office, but that remote office was just an ad hoc office, so it's not really connected to your office through a VPN link. Instead, you have a CMG up here that you're paying for. This is a CMG running in Azure. You're paying $100 a month for this one. Clients are getting ConfigMgr content from the CMG rather than from one of your DPs in your central site. If your site server has BranchCache enabled, everything that you upload to the CMG will also have BranchCache enabled. And that means that your client in that office will only have to download once, rather than all clients downloading from the CMG, because again, you pay for download. Why download more than you have to? And this is over an internet link of some kind. Why not make it use smarter so that only one client is getting the stuff over the internet? It was actually last week I reached out to the community and just asked for some real world numbers for the cost of using a CMG. And it's so cheap, it's stupid. But bottom line, here are some real numbers for you. Basically, everything below 3,000 devices was about $100 a month, with a cost per device of 4 cents. That's not stupidly expensive. Of course, we have 100,000 clients. Yeah, it's going to be more costly, but again, per device, dirt cheap. If you haven't played around with it, haven't used CMG, tested it, good stuff for sure. Questions?
No new questions. So if somebody has questions, put them in the Q&A.
Basically, if you're new to these technologies, get a lab going, set up a few routers, set up a bunch of VMs so that you can test different clients on different networks with different speeds. So you can learn all the limitations and how this stuff really works before you implement it in production.
I have some questions. One question. How do the caching options work in environments with a lot of laptops on Wi-Fi?
So both peer-to-peer and both peer cache on BranchCache actually works over Wi-Fi as well. That's for these technologies, their point of view is just another network really. But what I've seen in a lot of, especially large organizations, is they have fairly large Wi-Fi networks. They can be thousands of clients in a single VLAN for a Wi-Fi. And what the network teams often do in those scenarios, they use central controllers. So they will route traffic up to a remote site. So basically, say that these clients here, they're on Wi-Fi. But for this one to send data to this one, it actually goes over a central point and down again. And in that particular Wi-Fi configuration, would you say that doing peer-to-peer is a wise idea? No, it's not. You basically just download the stuff twice, once over the WAN link up and then over the WAN link down. So that would be a not good fit at all. What we do in our solutions is we detect when a client switches and we change the configuration of it. But otherwise, you have to adjust the client to do different things over Wi-Fi if you have that type of Wi-Fi configuration. If you have just a regular AP locally or you're not using a central controller, it's still fine to use peer-to-peer over Wi-Fi. It's still better than doing it over the WAN link, but you probably want to reduce the speed a little bit. And again, without dynamic control, it's a little bit challenging to do that. Because if these are connected, as I showed you before, I had my little gigaport switch, you can allow them to use as much as they want. But if you're peering, say, a 4 gig Photoshop package over 50 clients on a Wi-Fi network, I mean, we had one customer I worked with that had about 7,000 clients on Wi-Fi. If you would allow them to use the full speed, those access points, they will melt. Smoke will be coming out of them. So it's one of those depends answers. But yeah, from a networking point of view, Wi-Fi with a certain configuration will happily do peer-to-peer. Wi-Fi in other configurations will be miserable to do peer-to-peering in. In the scenario with central controllers, it's actually better not to do peer-to-peer than just download when needed.
Okie-do. A couple of questions still. What's the best way to set up a lab and get licenses for ConfigMgr, etc.? I guess using your deployment toolkit.
Hydration Kit is a good start to get the lab going. Thank you for that little pass. If you do search my blog for the keyword hydration, there's PowerShell scripts available that builds up the entire lab. Since the question was also around licenses, we test these kits with the trial versions of Server and ConfigMgr. The only downtime is that you need to rerun the script about every 4, 5, 6 months because the license will expire. However, ConfigMgr, as always, you're paying for endpoints, not how many servers you happen to have ConfigMgr on. So if you ask your manager nicely and say, hey, would you mind to buy like 20 more extra licenses, endpoint licenses? in addition to the 12,000 you just bought, well, then you can have real licenses in your lab and don't have to worry about resetting the lab every so often. But heck, I mean, trial versions are fully functional. The only drawback is they obviously expire after a while. I have to redo it again. Yeah. More questions?
Yeah, two not really related questions. One from Diak. Hi, Johan. Is the friend of OSD project still alive? And is it still working?
So I have to give some clarification to that. So me and a bunch of other people, we wrote a PowerShell extension to MDT that we call Friends of MDT. We just took the VB script code and converted it over to PowerShell so that we can also do HTTP and HTTPS deployments from VMs in Azure. So basically doing cloud deployment, but bare metal. This still works. I haven't done any code changes in probably a year now on it. It's very experimental. It only supports bare metal, but it does do deployment over the WAN link. But this is not ConfigMgr. That's MDT Lightouch only. I've heard rumors of that the product team are trying to figure out ways to do a bare metal deployment through a CMG. We'll see if that eventually happens. For now, you're limited to run servicing sequences over a CMG. But dang, it would be so cool if they can figure out a way to, from a WinP boot image that you initiate, to get everything needed from a CMG. Just to give you some perspective here, some hardware these days, UEFI hardware, BIOS settings, they actually support HTTP and HTTPS downloads. Macintosh have this, Surfaces have this in some capacity, but allow a time where we can just go into a BIOS setting and say, hey, re-image this machine. And it will re-image that box from wherever it is. Starbucks, at home, in the office. This is my idea. This is my idea of the future.
Yeah.
Not needing any boot media, not needing anything. I even saw someone back in 2015, they wrote an app for iPhone. So you can plug in an Ethernet dongle in your iPhone, and your iPhone was your Pixie server. So the iPhone had the boot image. But that project died, and I guess they couldn't get it to work. Plus, it apparently burned the phone after a while also. So, but it's interesting.
Yeah. So I guess one last question, also a little bit out of scope, but from Mark, what is the best practice of applying monthly quality updates during the machine build? Adding a software update step in the task sequence increases build time, which is not an option for us. It's SCCM offline servicing every other week.
No. Heck no.
Option. No.
You need a David in your life, that's for sure. This. This you need. This is a massive PowerShell module, 2 modules actually, that makes sure that your image is perfect before you deploy it. So I recommend using this one. It's just using offline servicing, but it's fully automated, it's well tested, and we work remarkably well. So I prefer to update the image before deployment. I do not like the steps in the sequence that tries to do updates during deployment. I do not like the schedule task in ConfigMgr that allows you to do the same offline servicing. This one is better, my opinion.
And one really last question then before we close off. What's your view about autopilot? Whilst it doesn't replace what SCCM can do in the terms of bare metal deployments, it can configure preloaded devices with Windows 10.
Here's the deal. Windows Autopilot currently is not OS deployment.
No.
Autopilot currently is just a technique to bring a machine under management. And for certain scenarios, that's a great option to do that. But someone better put Windows on that box first. And that someone is going to be either you or a vendor or a service partner or someone needs to put Windows on it. Until Microsoft can figure out a way to allow imaging through the same mechanism, you're still going to need both. You're just switching to who's going to do the work.
Yeah, exactly. They missed the scenario of, well, for instance, Mac pulling down the image from the internet on a brick device.
Yeah. I mean, you can still reset devices if it's not too broken, but if you have a bunch of devices where you need to do a re-image, or if you buy new devices, someone better put Windows on it before they shipped out to the company.
Alrighty, thank you very much, Johan, for taking the time and share your knowledge with us. I will share my screen for a couple of moments. Yeah, I'm sure I want to share.
Thank you so much again for having me. It's been great fun as usual.
Yeah, and hopefully we can get you on premises in the near future soon, which is always even better. But this was great. Thank you for joining us again. And we would love to ask you all in the event to provide feedback. I also added a message in the Q&A. It's our first time doing this via Teams Live. Hopefully it was suitable for you guys. Maybe a different way is better. Please let us know. And thanks again for our sponsors. And yeah, thank you, Johan. Have a nice day.
You too, guys. Thank you so much.
Thank you. Bye-bye.